I'm very happy to welcome again to Montreal Professor Vimla PATEL, who was the head of the cognitive science program at McGill before the day, and this is very early in its history. And she's now a director of the Center for Cognitive Studies in Medicine and Public Health at the New York Academy of Medicine. And are you also at Harvard, Vimla?
Pardon?
Are you at Harvard as well?
No, I'm at Columbia.
Oh, yeah, sorry, Columbia, right. And when she was at McGill, she was professor of medicine and psychology and director of the McGill Cognitive Science Center. Her early research was on the cognitive mechanisms underlying expertise and medical decision-making. And in connection with that, UQAM in its Department of Psychology will soon have a master's that's devoted to that kind of research. I hope some of the representatives of that will be here as well. For the past 2 decades, Professor Patel has been working on decision support technology and on errors in complex clinical environments. That's very much along the lines of what the psychology master's is going to be dealing with. Whereas right now, Vimla, we're in the cognitive informatics doctorate, which is in the computer science department and not the one that it's in psychology. Mm-hmm. She's interested in the role of cognition in biomedical informatics for a safer clinical workspace. The kinds of topics that she's dealt with have been interaction between humans and technology, cognitive design, distributed cognition. If we get to distributed cognition, we've had talks on that before, and we may raise that topic in the discussion, and team decision making. Welcome, Vimla, and go ahead.
Thank you. Thank you very much for introduction. So this talk is going to be somewhat unusual in the sense that instead of talking about one research topic, which if you usually talk about in a research seminar in greater depth beginning to it, I'm going to give you a more of a landscape of what is happening in the field of biomedical informatics, generally in healthcare currently, and where does this science of cognition play a role where we could be involved in. The reason I'm doing that is because the field is changing so rapidly. And if I focus on 1 or 2 studies, what will happen is that I would focus on 1 or 2 methodologies. And we usually tend to use certain methods for certain kinds of study. But in this case, particularly, what I want to particularly talk about today is to tell you how we started the beginning in the 80s, when I graduated actually, started working with the area of medical expertise in medicine, when what kind of tools and scientific information was available to us and what was important at that time. And how the healthcare has changed so much from there to now. And technology has really, the advancement in technology has been phenomenal. And the introduction of these technologies, particularly the health information technologies like decision support system, has been implemented in the clinical field for physicians and doctors and people other healthcare professionals to use without understanding really what it does, or without understanding the clinical workflow. They are never usually tested in the field itself. They are laboratory tested. Transfer is usually a problem. So this will give you a feel for how the field is changing over time and what other new methods are available. So I will give you some detail about the original research, which is still very relevant, and then subsequently give snippets of the research that we have been doing over time and more recently in the last decade, so that uses these kinds of certain computational methodology, which are very useful in tapping some information that we want to do. So there is a great need for cognitive scientists in this area. So basically, it's my plea for cognitive science to say, look, we need more and more people like you out there working in the healthcare, because it affects all of us and our health of our families and friends. And we need people to understand the science, because science takes a long time to develop and the technology advancements is much faster. So with that, let me just move to the next slide. Okay, let's see if I can go to here. All right, this is the landscape of biomedical informatics in perspective. People have different views on biomedical informatics, but this is particularly where the field of as biomedical informatics recognized by the endorsement of the biomedical informatics bodies who are certified in this. And it is an association for biomedical informatics in the US, and there is in Canada as well. And there's also in the international scene. So basically you have on the top level, the basic research, which uses methods and techniques and theories that come from very basic sciences into the more biomedical sciences to more biomedical informatics. And then we applied science that they applied in the various areas called bioinformatics, which is the genomic area with the genomic information, which is exploding right now. Then you have imaging, which is tissues and organs that you work with. And a lot of that area relates to the original work in perception that we do. The clinical informatics, where we talk about the clinical practice and the patients are involved, doctors are involved and other healthcare professionals. And these are really talking about how people, clinicians work in their field, in the environment. And then implications for all of that for public health informatics. In other words, how do we decide what kind of public policy or changes that we would make based on the evidence we have collected from all of these domains? They are not mutually exclusive categories, but this is what we call the health informatics. And this is just a name that's been given, organized, and accepted by the community. Doesn't necessarily mean they're hard, fast names, as long as you can define them. And these are not mutually exclusive categories. And as you know, as clinician practices in the field, they use genomic information, they use imaging information, they use radiology, they use information from various fields that are needed. So they are not, they are very much interrelated. Although most studies are done in the individual domain by the very nature that we focus down on something. And more collaborations are needed, of course, as we all recognize it. So given that, my work is mostly in the clinical informatics. I work in the basically how doctors work in the environment and how they collaborate with various people, including the technology as they develop. Now, I have been very lucky that I started very early in the scene at McGill, working in the hospitals where we didn't have much technology at that time. And there was no clinical support system, particularly the most useful one or that's currently being used or has been used for years is electronic health record system, or EHRs, which is basically when you go and see a doctor, what you do is they used to use, or some hospitals still do, paper-based. So they take your information when you give to a doctor doing the interviews in the history, they write it in the paper. All the lab data comes in the paper, they either fax it to you, they send it to you in some form, or some person delivers to you. All that information transfer between various entities takes a long time. Paper-based. Now we do everything electronically through this support system called electronic health record system, where all patient record is digitalized, is kept in it, and is used. The structure of digital health is somewhat different from a structure of a paper-based. So in very early in year 2000, when I was still at McGill, there was a clinic in the Royal Victoria Hospital called the Endocrinology Clinic, which was a diabetic clinic. Diabetic patients came in to see. I negotiated with a vendor, a development with Conch, which is a system developer, to lend me a set of computer-based patient record system to use in the hospital. We negotiated with the hospital to say, can we do the study so that we can take so many clinicians, something like 20, 25, and collect the data while they are using paper-based record, and then introduce the electronic health record system, which is the computer-based patient record, and then take their copies of their record keeping, and then 6 months later, remove the system, and they have to go back to paper. I wanted to see if technology had any impact in the way doctors organized information. The assumption being that if you organize your information, you interpret the organized information differently. If you, that means you would perceive and interpret it differently, which would mean your reasoning would change as well. So wanted to study that with the agreement with the hospital, agreement with the director of the unit, and be able to get a grant that called the Medical Research Council to do a joint study. So in that study, what we did, the organization of reasoning available that drives the decision process, that was the underlying assumption, and that the nature of the heuristic or the strategies for making this decision will change with decision support. That was the assumption. So we had something like, for each doctor, we had a number of patients that were recorded, but they were all controlled for example, type 2 diabetes, a particular kind of diabetes, a particular age group, and so on, as a good psychologist would do, a good kind of control study. And these are all reported data on the papers. So look at this example of a physician who uses, this is before using an electronic record. This is a introductory history of the patient. She talks to the patient and then writes the summary and says, this is a 74-year-old woman whose diagnosis of diabetes was made in February, and she had complained of. As you go on, it's a story, it's a narrative. It has a lot of and if and but, and that kind of conjunctive nature of the language. Language is a very important factor in medical, because most of the information is transported verbally. The verbal analog is very important, unlike the pattern recognition, which we do in the problem-solving literature. So it's something, it's equivalent to how people in psychology chunk information is like a pattern in a imaging area. So this is a very important factor. It's like a narrative. It tells a story, leaves very little to your imagination of what the story is there. So we collected so this was consistent with all the patient records we collected, with all the ones. Not a single one was deviant. The next one, we did analysis on what we call one of the methods of natural language analysis, which I was trained in, called the propositional representation. I trained at McGill with Carl Fredrickson in education psychology and in Walter Kinch from University of Colorado, and I used the methodology. And this is basically a language analysis. On the right-hand side is the header, and the left-hand side is left-hand side is the header, which is most often the verb. The right-hand side are the set of arguments, and with attributes, for example, the degree to which, and then you have a theme, you have aspect, but there's continuous or discrete. And as you will see, there is things called and condition, if then. These are all conjunctives. In other words, you can tell how many of the narrative, how many times they're using this conjunctive to quantify something that is qualitatively collected. Number of times they have used this kind of conjunctives or things that, like in the language, the structure that tells you that it is a narrative, okay? Now, if you start to look at the next one, which is electronic health, EHR, the information is captured in discrete form because that's how electronic health record systems are. Because there is too much information that patient gives you, you don't want all of it because there is relevant and irrelevant information captured. So you want to be able to separate the relevant one from irrelevant to help the doctor separate out by providing this structure. So this structure helps you to remove the irrelevant information, assuming that these are the relevant bits of information. So this is discrete bits of information that is collected. If you look at the analysis of that, you will see that in 1.2, there is a blank. And then in 1.4, the attribute, there is a blank. 1.6, there is a blank. These are blank things that has to be completed by whichever doctor is looking at this patient record, wherever this information is not complete. And there is absolutely no conjunctive, no add or if conditions or causal or anything like that at all. It's very simple structure and discrete information one at a time. And you can count the number of times. This was also relatively consistent with all the data we collected, okay? And then we went back to the, after using the EHR, went back to paper. And this was a surprise one for me. And then after using EHR, they were actually using the structure of the EHR, not the structure of the paper. So in other words, the EHR, this decision support system, had more than just impact of data storage or retrieval of information, but it actually changed the way they were organizing the information in their heads, which was, I wasn't expecting that. I was expecting a change, but not so dramatic. Now this was again, consistent with all the physicians, and which was another surprising thing for us. There are many other findings, but I'm just going to focus on some aspects that I want to talk about today. And then when we looked at the analysis, we found a similar structure again, a lot of gaps, and not a narrative structure. Now, so assumptions here, so after the study that we had to make a quick strategy change as to, wasn't expecting these kinds of data, what do we do next? So if we started to count, so left-hand side category is the categories of information that is written in the record system, whether it's a paper or whether it's a computer-based. The handwritten one is number of times chief complaint was used, average number of times chief complaint was used by the doctors, and the past patient history, lifestyle, etc. And the other one in the computer-based system. The blue arrows show you that the chief complaint and family history went up in the computer-based, but these went down. Now, it's not important what implication these has for the patient, but the more important for our talk today is the moment you have reorganized the information in front of you, you have different interpretation. You perceive the information differently. So anytime we might have the same information, but it's reorganized, it isn't the same interpretation you give. It's slightly different. Sometimes if you're an expert, you can figure it out long-term, but usually it takes a long time. So this is we showed the subsequent study that if you change if you give the patient, doctor a patient information like this one, and then you disturb the pattern like they do in the chess game, if you disturb the pattern, an expert cannot recognize it that quickly. It takes a long time. If you're not an expert, you can't even do it. Very similar to a pattern recognition of a chess player. A master chess player, grandmaster, can do extremely well when all the patterns are there. But when the pattern is disturbed, it takes a long time to recover from that. So if that's the case, assumption here being that if you change the structure, if you change the interpretation, then the strategies that develop from it would also change. So here in the patient record, you have patient data. Yeah, and then we found that they used the patient data in paper-based to generate multiple hypotheses. Okay, so multiple hypotheses in the electronic health record system, they started with the hypothesis because the support system gave them guidance, saying you got so much information to process here. Let me tell you, do you think this patient has endocrinology problem, nephrology problem? Would you like me to narrow it down? So you'd select a hypothesis, a tentative one to work with, and then you'll use that to interpret the patient data. What it really means is that you are now reversing, the inference is driving in the opposite direction. You're using data-based, data-driven inferencing to generate a hypothesis versus hypothesis-driven reasoning to explain the patient data, which is very similar to the forward reasoning and the backward reasoning, not unlike the computer science of forward and backward chaining, although it's not exactly the same. There's a difference between chaining and reasoning. And when we went back to the paper, it was exactly the same as the electronic health. So it has an impact. Technology has an impact on the way we organize and think about and reason with it. So if it does have that kind of impact, we've got to be very careful what we put out there, that it will change the way they think, and it might impact in the long run in a way we do not want it to have impact. This was kind of important study that made a big difference of subsequent my studies. We studied a lot of doctors with hypothesis generation, with data-driven hypothesis, a number of studies to confirm that this is something that this could have a negative impact if it's not controlled carefully. In the process of decision making, usually you perceive the patient information, which is basically you're trying to comprehend it and you represent and you interpret, which is a very fast process. And most often you look at the interpretation to infer the representation, then you make a decision. Now, the cognitive support is often given at a decision level. Do you want to have a decision A or do you want to have decision B? We still do not give support for cognitive system at the level of comprehension, at the level of interpretation or representation. We desperately need support at that level to provide information in electronic health system. We don't have that, still don't have it. And because it's more complex to do, we need to elicit information in real clinical world to be able to decide what kind of support is exactly needed. We need to know the structure of the information. It's time and effort. And even if you do a lot of research in this area, vendors usually don't want to work with you to produce these systems because it's a time on task and also the money involved, and it takes a long time and it's harder, but it's desperately needed and an important factor to consider. Over the years, the studies we had done is that clinicians that we show, and subsequently other people have shown, that clinicians, doctors, do not use scientific information in their daily routine practice. They use heuristics, they use rule of thumb, because they kind of have learned it over a period of time, because it helps them to make quick decisions. But they fall back on science if they have uncertain on this complexity. When there is a real complex and confounded uncertainty and complexity to some extent are confounded. And they reverse, they actually go back to think about it, but otherwise they move forward. And the science that underlies bioinformatics, like genomics, is constantly developing, changing. Clinicians have to use now latest genomic information because people demand it. I want to know that information in my trying to diagnose my disease. But they haven't really developed any decision heuristics yet because it's new. It's constantly developing. So keeping abreast of science at the same time, trying to integrate science into practice is not trivial. These are the challenges we are facing and kinds of things we really need in the world of complexity, in the complex healthcare domain. But these are studies that constantly are still being done, but reaching at the level we want to reach to have an impact is not easy. So over the years, the studies that I had done changed from controlled individual. I was very much came out of symbolic representation world, really hard-nosed, believed in it, and I still do. I haven't changed my mind on that one. And very much followed the Carnegie Mellon tradition. Controlled experimentation, understand how they think, reason through the basic principles. All the work in the laboratory individually started, simulation, hand simulation, scenarios. For a few years, we did the studies, but scenarios were developed, real world scenarios from the hospital, because I always had the hospital appointment, which made my life easier to collaborate with them. Given that I have a biochemistry and microbiology background and some medical background that will help me work with them. Then over time, I realized not all variables were I could account for in the data. So moved slowly towards quasi-naturalistic in clinical teams in the clinical world, because the healthcare spectrum was changing. Doctors start to collaborate. Various healthcare professionals collaborate. They don't work individually anymore. We started to use very classical methods of audio recording, observations, semi-structured interviews, various kinds of traditional or classical methods, or I like to call it, time motion studies, to collect rich data. And they were extremely good and very rich and valuable, but very time consuming. Coding of the data, analysis of data, all hand done. But we all learn from basic principle. I taught my students from basic principle because we didn't have much other support, technology support to data, collect data or analyze data. So we, over time, as we collected more and more, we understood the naturalistic, we understood the clinical domain, we understood the clinical arena, how they work, what are the constraints on decision-making. Not only the cognitive, which is the memory, the knowledge, the reasoning strategies, but also the socio-technical constraint, the organizational, the constraints that make decisions now. Therefore, systems that were now being developed didn't really take into account all of that and never were evaluated in this. So as we move more towards computational world and more technology advancement out there, we started to use a lot of other methodology that we could use to collect and analyze data. One is called sensor-based technology, contextual computing. So I want to bridge now more into that world to say how the landscape has changed, what are the snippets and what are the examples of specific methods we have been using in various studies that would show you how we have capitalized, leveraged the current technology to investigate and analyze something that we used to hand code. And concurrently, of course, in this world. So we work with the people who are in the AI world, artificial intelligence world, who are more interested in augmenting human intelligence rather than the other kind of AI who are developing the systems for different reasons. So we collaborate with them. We collaborate with many other people like cognitive anthropologists to be able to get on anthropology to understand ethnography. So in a real cognitive science sense, we use a lot of multiple methodologies borrowed from many areas. For in the clinical world, I borrowed methods from cognitive anthropology for real-life observations semi-structured interviews, details of them, trying to understand, used computer science methodology for forward and backward chaining and reasoning, trying to relate comprehension to problem solving and decision making. So now we're moving more into a lot of other kinds of worlds that relate more to the broader cognitive science community. So in the clinical environment, when you implement any kind of technology, there are unintended consequences. You don't always expect things to happen, but it happens. And if we don't try and understand what they are and correct them, people get cognitive burnout completely. They get exhausted and they don't want to use it. They get frustrated and they find, and then they just resort to the basic principles, but they know best, the paper. And the types of errors and nature of errors they generate are horrendous. And there's a whole field of errors that I work with, and the kinds of errors that are generated. Most vendors and most people who even do research in this area, they test the technology only in the laboratory. And simple asking the user, what do you like this technology? Do you like the navigation? What part do you like and what you don't like? Because it's a quick and dirty way of doing it. Now, there is a value in it to quickly move on, but to put the first generation out there, but that isn't enough. And then the clinical workflow, you have to understand how people work. The whole notion that we are going with is we want to augment, using this technology, augment the human intelligence, to augment human activity, to make it better, to help them. And clinicians want control of some things. They want to be able to do it, but they want to do it better. They just can't process that much information. They need help. But what kind of help is given and when is it given is the critical point. So clinical workflow, one of the things that we use a lot now is computational ethnography. The advantage of this is that we have the thick description of ethnography, which is the observation. At the same time, we use the precise and the more continual support, precise method of computation. So we are combining the two methods to be able to use. It's an in situ, means in situ research doing in place that uses technological means such as sensors, technological time motion tracking. I will walk through some examples with that. And interaction logging, for example, security digital logs. Now it's available to us. It's available in the hospitals to collect precise, continual, and unobtrusive. People don't like being interfered with while they're doing their task of everyday behavior with daily tasks. This is
sorry to interfere, Vimla. I just wanted to mention that we did have a past talk by Marta Kirsten Ertl about what you're talking about right now, which is the use of sensors and
okay.
means. Yeah.
Oh, great. That really helps because so you're quite familiar with it. So this is used in the clinical world, which has its own challenges itself. But continual is very important, not only precise, but it automatically collects the data. So you don't have to stop and analyze it and stop and say, well, now what do you think? And maybe put it again and see next generation. It continually just do that. You don't need physicians' help there. You don't need researchers to go and collect data. It continues to do that. So, and the sophistication of these things have changed dramatically from where I started. When I first started in 2007, and the first digital things I started to use, we were using clunky, this big technology, even though the digital things were clunky. Now there's so little able to collect data. Battery life is so long. You don't need to change every day. It's really wonderful. So leveraging automated means of collecting data is reflective of the real user, unaltered behavior in real setting, to be able to do that. Unfortunately, we need a lot of permissions to be able to do that, through people, this kind of research, we can't just do and go and collect it without their information, without their permission. Based on the premise, based on the premise that when any time we use a technology, use a computer, that a doctor clicks on an electronic health or support system, it leaves a digital trace behind that you can be utilized or fully, partially reenacted the activities. You can actually reenact what exactly happened. And that's exactly what it is, that you can trace. So when a mistake is made, we can backtrack and say, where exactly in this, in the interaction with the patient or interaction with the environment was the error occurred. This has been very valuable to us in that perspective. So this is an example of one study that I want to give, although done a while ago, it's pretty pertinent. It's a analysis of one of the decision support systems, which is part of the larger electronic health, called computer provider electronic provider, the medication support system. So it is a part of a support system that provides you with medication. You can add the medication, you can subtract medication, and it keeps a digital record of what you do. So it does it automatically, but there was a mistake made that where a patient was overdosed at Columbia Hospital and overdosed with potassium chloride. It doesn't really matter, but it's a dangerous drug, and it should not have been given that medication at that high level. So the assumption was building, if you don't do any investigations in detail, the assumption is doctors are not trained properly, or the system is really not good, and the vendor should change the system. But how should they change the system? And how should we train the doctors is not really quite clear. So I was called in to investigate to see what exactly happened. So I agreed with the vendors, with the hospital administrators, that we'll study this in detail. We'll do the digital trace. I would need access to all digital logs, everything that was done from the time the first patient arrived and they clicked in the system to the last time the patient went into coma and had to go to another unit. And we had available to them, we were able to interview the people concerned and collect the data and publish the data as well. So this is the digital trace of, just to give you an example of what data logs in the hospital look like. And this is on the left-hand side is a resident, is a house staff, or he's a physician or she's a physician, but it's a physician A, but he's a trainee physician. And then there's an order number, which order was given, the status of the order, whether it was discontinued or was still active, the generic name of the drug, the brand name, and how much dosage was given, 10 milliequivalent, how frequently it was given. And which way was it given? Whether it's given through the IV injection, was it given by a mouth? What time it began and what time it ended. As you can see on the red, on the right-hand side, the red, the timestamp, which is very important that it was done. Pardon me, I just want to go back again. Very important to show how often that you can keep a track and the time. Suddenly you often see that they keep clicking on the things, system won't react number of times because the user interface was so bad that the medication kept adding without the system reacting. So, and nobody had any idea that medication was doubling, tripling without any system. As time went on over a period of time, in a short story, when resident B came on the area, it didn't see that the current medication is still going, ordered more medication, and finally resident C came in and ordered an additional 20 milliequivalents, which really the pharmacy freaked out and said this is a really high dose. But the pharmacist gave out the additional bolus and it was used and the patient went in coma. Now, why would all this happen? a number of confounding factors, not only by one physician, not by two, but by three, including the nurse, including the pharmacist. It's like a Swiss cheese with every hole lines up. So this is a intravenous, if people are not familiar with the hospital setting, this is the intravenous saline. There's a little bag on top that usually runs, the medication is usually runs through that. The medication is given through the saline. But when you give additional bolus, you decide that the patient is really in trouble, we need to give them extra bolus, which is calculated separately, is given through injection separately through the saline, but a very separate route. Okay, there were many problems with the system. There were user interface problem, but one cognitive challenge was that the screen on this computer provider order entry system for intravenous drip and the IV bolus, which was given additional bolus, was superficially looked very much alike, but required a different mental calculation. The IV administration usually, which is most often given, and also system is organized that way, is milliequivalents of drug per hour, saline drains per hour. The bolus which is given, doses specified by dose, so infused with so many milliequivalents, not by hour, not by timestamp. Calculating the correct doses to be infused is essential, but this was not supported by the technology. The user interface did not provide the tools to help in this. Rather, it actually hindered in this case. The interface was a poor fit for calculations required by physicians. In addition to that, there were many other problems, but this is the one that required understanding of how doctors work in this area. How do they use these devices or these technologies? What is the nature of their work, so that when you implement something, you understand it better. My students in engineering and computer science, whom I teach human factors and human computer interaction course, they all want to come up with an idea. I want to develop this app. I want to develop to help the nurses in the emergency room or in the intensive care unit or in the operating room. Have you ever been to the operating room? Have you ever been to them? No. Well, you're not going to develop anything until you've been there. So I take them all and introduce them to all of this area, and they have really changed their mind as to how they're going to design it. And I assign them to individual physicians or other healthcare providers, so that they can spend some time for a number of days to understand it, and before they start developing an app or a system that is supposed to support them. The message basically is that overdosing, the overdosing case study, this particular one, exemplifies a larger problem. The decision support is, as intelligent as may be, seldom aligns with the mental processes underlying clinical decisions. So you need to really collaborate with people who are designers, people who are clinicians, the users, and the other people who understand the process-oriented work, including psychologists and computer scientists who can program some of this. So this is one use of digital, and there are many other uses of digital we have used over a period of time, but there's one specific case in point. Other sensor-based technology is that we use is this clinical workflow. Now, this is the pocket tag on the right-hand side, which is a little tag, a digital tag that physicians carry on their pockets now. When I started, it used to be a clunky big thing. They used to pin them on top. Big thing they used to have. It was a heavy to carry, low battery life. Every 12 hours, every 6 hours, we had to go in and change the battery. We used to take turns, middle of the night, to go and change it. And sometimes they will walk away with it, they will lose it, we had no idea. Now, this is all put on the wall. They come in, you can't sign in the electronic record without pulling out this tag. You pull this tag out, and then your name is on it, or name or coding number is on it. Then you can sign on the computer. and then you put this in your pocket and it traces you. So we had many places over a period of this is a miniature sensor. It's a tiny, tiny one. Now, I used to have big clunky ones put on the center of the floor of the hospital. Now we put it on the hospital, as you can see, installed on the wall. And it can, after much experimentation and work with the distances and where exactly how much distance it's going to cover, you put it on the wall and covers. This is from Mount Sinai Hospital in New York. And we had a number of hospitals, studies were done. We had the New York Presbyterian Hospital. We had studies in Mayo Clinic in Arizona, in various other, in Texas Medical Center. So all these studies, this is one particular one where on all these red dots are all the places where we have kept tracking devices and the movements of the people they can move along the way. So we can trace them all. Now, and then the tracing looks something like that. This is the tracking, the kinds of circles, if you have already done the technology, you know what they are. They are each of the dots are various, and colors are various providers, and the lines are interaction. The strength of the line, the thickness of the line will tell you how often they have interacted. So over a period of time, you see this changing, the pattern and how often. What you don't know is why are they communicating? Why are they interacting? Not communicating, why are they interacting? And what are they communicating? So we have now started to use start to test little microphones with some subjects to be able to record what they're doing, a few of them. It's in a testing phase to be able to not only say what they're doing, but how they are and why are they doing what they're doing. Am I moving closer to someone because I just want to talk to someone, or I'm collaborating because I'm copying because I need to pass some information that's vital to the patient. And then we used to be able to code with hand. This is called the time belt. How much time doctors, nurses spend, time distribution with clinical activities at each site. Now, these are two sites. The top one is an academic clinical center with clinical workflow. The other one is a community health center. One of the key questions we normally ask everybody that we are having far too much interruptions, multitasking, and there is so much work with clinical activity we have to do. It takes too long to document patient record and able to come up with a time from the time you document to time we make the final decision on the patient. All that makes a huge difference, and it creates extra cognitive load. Can we reduce all that by some kind of technological support? So we decided to actually look at this time belt, which is this time distribution of how much time they precisely spend on each of these areas. So these we started with site A and B exactly the same time, at the same level, so that we coordinated the two sites carefully and time belt. As you can see, there is a lot more team communication in site 1 than in type 2. There's a lot more multitasking in site 1 than site 2. A lot more interruptions. Now, pattern, if you look at it just observationally like that, quickly in the pattern, one will assume more interruptions is really bad news. And the other one is so efficient, and we found they actually got through the patient out the door in the site 2 very fast. Site 1, it took a long time. Everybody's interested in efficiency. Not everybody looks at the safety. Safety was compromised in site 2 because they don't have team to offset some of these. So this kind of method required observations to be able to see what happens. Because in the academic side, you have trainees, that collaboration, that people are spending time in teamwork, in collaborating, in talking to each other. They're training the students, residents, And during the interaction, there are team communications. There's somebody else to check if you made a decision, somebody checks your decision. Nobody checks a decision in Site 2 because you work individually. So what are the factors that you offset, trade off once against the other? You're trading off safety for efficiency. Here you have efficiency, but safety is kind of a marginal thing. So these are the questions one asks. Where do you draw a line? What are the nature? So one of the things we have learned that in complexity science and the complexity area, complexity isn't always the bad thing. It actually sometimes saves lives in the emergency unit kind of thing. There's some things that are necessary, but what is it? What is the nature of this complexity that we need to worry about? So those are the kinds of data we collect. There's a number of these kinds of methods we use to complement other. And this is the one last one I want to talk about quickly is navigation. This is a colleague of mine, Kai Zhang, who has done some wonderful studies, very similar to what we have been doing, but his data is more illustrative. I can explain to you much more clearly than mine, which is slightly messy. This is what the system was designed to do. In the electronic health record system, this is how a doctor was supposed to go through the system. And this is how people actually navigate. These are all the doctors, how they navigate. Not exactly the same day. Day-to-day practices are very different. And this is this is not what this was designed for. Design was for linear work. In the complexity area and the complex area, this work is not linear, it's non-linear. And the parts don't make a whole. So very different nature. And these are not designed. So this is a tricky issue. So when you start to do that, it interferes with the utility of the work flow. The final challenge we have with all of this is we collect all this data. Okay, so we have observations, we have interviews, we have digital data. At some point in time, you want to develop a model, really model of what's going on. You need to overlay this data in some form. And this is where the challenge arises. How do you overlay this data to say, what is each one of this data saying? And what kind of model can we come up with based on it? So this is where we are at, trying to overlay these multiple forms of information, trying to do visualized data, against the observation data, interview data, data logs. So right now they're all individually done. We're trying to do that. And this is where we are at this point in time. So these are some of the methods that we are using. That does not mean there are other methods that don't exist, similar ones that do exist, and some of them are very sophisticated. And this is what we can deal with in our lab. So a science and a caveat. The science of cognition needs to drive decision support system that can augment human behavior. We really need to understand how people in the unit, in the team-based work, how the work is distributed between the patient, the healthcare providers, and when you outsource that distribution to other people, the people, for the young people, adolescent clinics, we need the elderly homes. How these things are outsourced and that is distributed among all of these. And how do we support that distributed cognition to that extent? And what is nature of that over a period of time? There are many hidden variables, that defy really adequate consideration, that we can't even think about it. When you collect these millions of data, like deep learning system, they're all important, but they will not substitute for the basic science of cognition to understand it. And to appreciate the deep learning, you need many, many sources of data and lots of data. It's not so easy to collect that much data in this kind of area, unless there are just data points and not rich data like this. I would like to see long run, rich data like the ones I described, to be at the level that we can actually start to collaborate with the deep learning systems. Advances with more powerful systems will likely generate unexpected problems, needless to say. but means that we need to continually investigate for the problems and fix it as we go along. And we desperately need to collaborate efforts between researchers, the scientists from everywhere. As you can see, this is a live clinical area. We need anthropologists, cognitive anthropologists who understand the thick and the rich descriptions. We need computer scientists who can program, who can do things in this area. We need engineers. We need people who can artificial intelligence area. We need clinical communities, all the people who can collaborate, and all the people who have vested interest in this. Needless to say, administrators have to come in sometime. That would all lead towards, I'm hoping, this resurgence of a special interest, new interest in computational models of human cognition. I'd like to see more move towards it, but we desperately need more of this area. And we don't have enough people who step in the boundaries of this, because it's very difficult to get funding in it, because you fall between the cracks. Where do you apply for that? Where do you go? If you get too much in the science, the application areas will not support you. If you go into application, the scientific area won't support you. So you have to kind of juggle with multiple collaborations. And the people have recognized this desperately. They are calling out for us to do that, to be able to use more and more. And I'm continuing as long as I can to push these boundaries. We hope to do so. So I hope that some of that was helpful. And
okay, thank you ever so much, Vimla, for coming.
Welcome. Sorry, some of the questions I couldn't answer, but that's about the limitation of my knowledge.
Okay. Thank you very much.